When I explained the extended UTXO model in the first lecture, I explained that in order to unlock a script address, the script attached to the address is run, and that script gets three pieces of input: the datum, the redeemer, and the context. And in the second lecture, we saw examples of that, and we saw how that actually works in Haskell. We saw the low-level implementation where all three arguments, datum, redeemer, and context, are represented by the data type. But I also mentioned that in practice that is not always used, and that instead we can use a typed version where datum and redeemer can be custom types as long as they implement the from data type class, and where the third argument, the context, is of type script context. And the examples we have seen so far only looked at the datum and the redeemer, but we have always ignored the context. But the context is, of course, very important. So in this lecture, we want to start looking at the context. And this script context type is defined in package Plutus minus ledger minus API, which is a package that until now we haven't needed, but now we do need it, and I also included it in this week's Cabal file. And the context is in module plutus.v1.ledger.contexts. And we see the definition here. So the type script context. And we see it as a record type with two fields, one of type txinfo, which is the most interesting one, and then a second field of type script purpose. And the script purpose type is defined in the same module here, and it describes for which purpose the script is run. So the most important purpose for us will be this one, the spending purpose. So this is what we have talked about until now in the context of the extended UTXO model. So this is when a script is run in order to validate spending input for a transaction. But there are three other purposes. The second most important one is the minting one. So that comes into play when you want to define a native token, and then the purpose of the script will be to describe under which circumstances the native token can be minted or burned. And then there are two more purposes, rewarding and certifying. So rewarding seems to be related to staking, and certifying to certificates like delegation certificates. But first we will concentrate on the spending purpose. So now the actual context is in this field of type txinfo, which is defined also in the same module here. And this basically describes, it's an abbreviation for transaction info, so it describes the spending transaction. I always said that in the UTXO model that Cardano uses, the context of validation is the spending transaction. So the transaction and its inputs and outputs. And that is expressed in this txinfo type. So there are a couple of fields that are basically global to the transaction. And then in particular, we have the list of all the inputs of the transaction and the list of all the outputs of the transaction. And these txin-info and txout types again have lots of fields to allow you to drill into each individual input, respectively output. So let's go through the txinfo fields briefly. So txinfo inputs, the inputs, txinfo outputs, the outputs. Txinfo fee is the fee, the transaction fee. Txinfo forge is the amount of newly forged native tokens, or if it's a negative amount, newly burned native tokens. So we'll come to that in a later lecture. Then we have a list of certificates, something like delegation certificates. Then staking withdrawals, so withdrawals from rewards. Then txinfo valid range denotes the time range in which this transaction will be valid, and we'll talk about that in much more detail in a minute. Then the txinfo signatories, that's the list of public keys that have signed this transaction. txinfo data, I mentioned before that spending transactions, transactions that spend a script output need to include the datum of that script output, whereas producing transactions that send money to a script address, have an output at a script address, only have to include the hash. So this field txinfo data is basically a dictionary from datum hash to data to include the full datum values belonging to a given hash. As I also mentioned before, spending transactions always have to include the datum of the inputs they spent, but producing transactions optionally can also do that. And finally, txinfo ID is the ID of this transaction.